2, 1. And I'm going to close that so I don't immediately hear myself speaking. I probably missed a tab. Like I'm going to hear myself speaking in the background somewhere anyway. And we're live. Cool. So hello, everyone, and welcome to another Nomad Community Office Hours. Today we've got Michael and Charlie joining us, and we're planning on doing a couple of different live demos for you, and we'll be talking through some of the features that we've updated in 1.1.2. But just before we get to that, I just wanted to remind everyone that there is a code of conduct. So if you plan on participating in chat or asking us questions or talking to us, etc., just please be mindful. You can check it out at hashicorp.com/community-guidelines. I'll drop that link in the chat. And just generally, just remember to be welcoming, inclusive, friendly, and patient. Consider it respectful and professional. And with that, I think I will hand it over to Michael to do an introduction to everybody.
Great. Hi, I'm Michael Schurter, the Nomad team lead. I'm Schmichael on GitHub and just about everywhere. There's just too many Michaels in tech. Yeah, I've been on the Nomad team for almost 5 years now. Soon. Yeah, so Charlie, I'll let you introduce yourself.
Hi, I'm Charlie Boycell. I've been working with Nomad now for about 4 years. I'm Nomad adjacent. I've done Nomad support and Nomad education now for 4 years. Still rocking and rolling, but this is my product, my jam right here.
I know how to build the thing, and Charlie knows how to run the thing. I think those are our superpowers combined.
They're very complementary skill sets to have together on a live stream or when doing things together with the product. That's for sure. Yeah, and I've missed myself. So I'm Jacquie Grindrod. I'm a developer advocate here at HashiCorp, and I generally work with Nomad. As we're kind of going into the rest of this year, there's a bit more, I guess, Waypoint and Terraform and Packer and Console and Boundary. And pretty much everything. There's probably going to be some Vault coming up for me, but I'm still mostly here focusing on Nomad. Yeah, and so what we kind of wanted to do today was, it's been a little while since we've had just a normal office hours. The last couple I think we did were like KubeCon and conference adjacent. And then actually Charlie was on one of the last ones too, where we talked about community involvement with the product. So we thought it'd be kind of nice to just run through some of the features that we've updated since 1.1 and give a couple tech previews or demos. And I just kind of wanted to say that if the tech previews and demos and things go well, maybe this is something we can see more of in community office hours. And we don't always I guess we always ask for feedback, but this is a great chance for us to have like an early feature that we're showing. So if you have use cases, please share those with us in chat. We want to hear them, and we can kind of bring that back to help consider how we're going to build out the roadmap. We can circle back to that at the end of community office hours. I just wanted to make sure I said it before I forgot to. So with that, I guess, Schmichael, do you want to kick it off?
Yeah, sure.
Nice.
I think I'll kick it off with a little demo of CPU cores, that a feature that was new in Nomad 1.1. Should be pretty short and sweet here, as long as, I actually figure out how to share my screen. And there's a toddler knocking at my door. Does the bruise on my forehead shows up just a little bit. That was from playing chase with a toddler last night. So it's always an adventure around here. Let's see. Here we go. So the let me quick at my door. I'm sorry.
The joys of working from home. I think there's always something new that comes up. When I was emceeing Hashi Talks last week, I had a little doggo that was like, I need to sit on your lap right now. And I just was like, okay, but I'm doing Q&A. And he's just like, no, just have to be here right now. So.
Oh no. Okay, I'm back.
I'm anticipating a cat too.
Yeah. Oh yeah. It's always nice. Okay, let's try this again. Cool. Let's talk about CPU cores, huh? That's a good thing. Oh, this is a cool project too. I'll see if I can work that into a demo as well. One of the engineers on HashiCorp Cloud Platform, our cloud platform team, they use Nomad to run all of our cloud services. And so they wrote this cool little tool like it's inspired by K9s for Kubernetes. But yeah, just a really cool text user interface for Nomad. Let's see here.
Hey, Michael, you may want to bump that up a bit.
Oh, right. Everything's probably tiny.
Yeah, it's a good
I'm sorry.
catch.
Oops. My terminal's probably going to be tiny as well. All right, we probably don't need to jump straight into the scheduler code. Although, hey, here's the scheduler code for it. It's kind of funny. This is like actually most of the scheduler code for cores. So CPU cores was a new feature, and just to take a step back and maybe not dive all the way to the bottom of the stack from the very beginning. CPU cores was a new feature in Nomad 1.1. It's just a new way of specifying the CPU requirements for a task. Prior to being able to specify cores, you could only specify CPU shares, which were in megahertz. And that's a really awkward unit to have to think about your projects in. And so we added the ability to specify resources. There we go. Hopefully that's better. Specify resources in just the number of CPU cores. And it should be, pretty straightforward and intuitive to use. And Nomad will just ensure that if you have 8 cores on a server and you have jobs that all want 2 cores each, only 4 of them will be placed on that node. So it all should be fairly intuitive how this works. Should be just kind of a nicer way of specifying those CPU requirements than having to calculate some megahertz. Or let's face it, nobody ever calculates those, like just trying to guess at how many megahertz. One important thing to note with CPU cores is that, like specifying megahertz, it is a soft limit by default. So if you specify 2 cores, but it gets scheduled on a server that has 2 other cores idle, your task may use up to 4 cores. So by default, CPU just tries to use as many idle resources as there are. And so you can kind of think of both cores and CPU in megahertz. Both of those resources are kind of like the lower bound for resources that your task will ever get. So anyway, let's see if I can show it in action here. So I just use our little example job file. If you just run nomad init-short, you'll see something a whole lot like this job file. Oh, it's not HCL formatted. I'm going to get in trouble for that. Let's fix that. There we go. Now it's all pretty. Bump this up a little bit again. It's just a Redis job, mainly because it doesn't really matter what we use here. Just kind of want a standard Docker image to work with. And you can just see, whereas by default, the example job uses CPU and megahertz for resources. I just replaced that with cores equals 2. And like I said, by default, that's just kind of the lower bound, the lower limit for the amount of CPU that will be made available to this Redis job. If you actually want to use CPU pinning, or make it a hard limit to only use CPUs, then that's a driver specific feature. And so in Docker, you specify that by specifying CPU sets. And so this is a way of specifying that I'm restricting this task to run on the 1st and 2nd cores on my laptop. So let's see here. I think that's all the interesting stuff there. These terminals got all mashed around, but point being, I'm running a Nomad server, a couple Nomad clients. We'll use those a little bit more later as well. Let's actually run the thing. If you haven't upgraded to Nomad to get the new deployment UI or text output that you're seeing right now, you definitely should. This is super cool. The Nomad run used to just return as soon as the evaluations were created for what you scheduled, and there was like you might actually get all the information you wanted. Like if it was fast enough, you might get the allocations too. But now it'll just by default wait for the deployments and give you all the information about how the deployment is going, which should be way nicer and save you, the extra step or two of looking that up yourself. So let's see, everything went well there. Nothing too surprising, the Nomad status output, hopefully. If we take a peek at the allocation itself, you can kind of see, task resources. We still kind of give these live stats just in megahertz as before. Let's quick peek at it in the Nomad UI. So one sad thing about CPU cores is we haven't updated this graph in the Nomad UI to support CPU cores. We have, did I close that tab? Ah, shoot. That tab is gone, but I had the issue up in a tab. We intend on fixing it. But if you hop into the Nomad UI and are sad that we're not displaying things properly when you use cores, we know. Feel free to always +1 issues. We love hearing when people care about issues, but yeah, we'll get that fixed. There's nothing wrong functionally. It's just a display issue. Let's go ahead and jump in to exec and cause some trouble actually. So this is just the Nomad exec feature that has been around for a while in Nomad, where we can get a terminal inside the Docker container and get up to some hijinks. So let's install some packages and cause some load and see what happens to the CPUs. Okay, so I just installed a stress package. This is a way to simulate CPU load. And sorry that this is probably tiny. Keep forgetting that. Well, the important thing is that this should take up all of the CPU on 4 cores, but we not only have 2 cores specified for this job, but we also set that CPU set to be exactly 2 cores. So I should run that, and it's hogging 4 CPU cores. And if we just look at my machine, Zoom is taking up a bunch of CPU. But yeah, perfect. So you can see all 4 of those stress processes running, but if you notice, none of them get over 50%. And if Zoom wasn't taking up, well, actually, you can still kind of see it. If you look at the top of the screen here, you can see how my first 2 cores are pegged. And so that's exactly that CPU sets feature in action. It's restricting all 4 of these stress processes to the first 2 CPUs, because there's 4 of those processes on 2 CPUs. Each of those processes gets 50% of those CPU cores. And this is kind of everything working as planned. I mean, except Zoom taking up tons and tons of CPU. I wish it wouldn't do that. Oh, and I see that there was a question about, is there a way to specify this as a float? Not right now. And the reason for that is because we wanted to keep parity with CPU sets. This feature in the Linux kernel and where you can pin to cores. And the more kind of directly we can map that, the more flexibility, or the easier it makes it for task drivers to kind of implement sensible things there. Yeah, we might be able to change that in the issue. Definitely feel free to open an issue for that. We could definitely discuss that. But yeah, right now, the reason for this implementation is to fully support reservation. And would Nomad be able to schedule tasks accordingly with the kind of core they actually need? Oh, that's another great question. Right now, no. So this is kind of, I would say, table stakes, minimum viable core scheduling feature set. There's a bunch of exciting things we could do with this. for example, a big reason that people like to use core pinning is not just to kind of institute hard limits and fix noisy neighbor problems, but also because of NUMA, non-uniform memory access architecture. Do I have, oh yeah, I even have a pretty picture. So my laptop thankfully doesn't have NUMA, but there's a cool little Linux command for being able to look at it. And so what NUMA is a way of saying that it's cheaper, and this is going to be just a horribly oversimplified explanation, I'm sorry, but it's cheaper for some cores to talk to some memory than for some cores to talk to other memory. And if that sounds confusing and complicated, that's because it is. But if you look at my laptop, it's nice and simple. I have these 4 cores down here. Each of them have 2 hyperthreads. I think that's what this is saying down here. Some cache we can ignore. But then this NUMA node up here is saying all of my memory is equally accessible to all of my cores. In a lot of servers, that's not the case. So this is just me Googling some random server. And so this would be an example of a server that has a NUMA node per set of cores. And so it's cheaper for these cores to access this memory than it would be for these cores to access that memory. So right now, Nomad doesn't really help you out with optimizing your core to NUMA node mappings or anything like that. That's something we could investigate in the future. Again, great thing for us to get issues about so we can discuss it and figure out use cases and best usability. But yeah, this is kind of the future problems we could solve with our core support is optimally placing jobs so that they have the work within a single NUMA node for optimal memory performance. I'm sorry, this was supposed to be the short demo. I just really...
No, this is great. You're fine.
Remote task drivers? Should we talk remote task drivers?
Yeah, let's talk about remote task drivers. This sounds good.
Cool. So remote task drivers are another feature that we shipped in 1.1 that I've been playing with and developing for way too long now. We have a user that's been really highly engaged and great to work with. They're really interested in managing ECS tasks with Nomad because they use Nomad for other services. They would love to make it easier for their developers to take advantage of ECS. And so we're just kind of exploring how we can do that. So if you note in the Nomad changelog or our blog post or anything like that, we're always really careful to use words like technical preview with remote task drivers. And that's because, we want to get feedback before we really guarantee API stability and that sort of thing with remote task drivers. We take backwards compatibility very seriously with Nomad. In our changelog, you should always see every little change that could affect backwards compatibility called out. And so we wanted to label remote task drivers, as defensively as possible to kind of give users the biggest opportunity to give us feedback and have a lot of impact into the design of this as possible. But anyway, enough about that. Let's get into what it actually does. Here, we can get rid of this job. Don't need you anymore. So for remote task drivers, we wrote a demo driver for ECS. Again, you'll see us spray experimental all over this stuff, especially because this demo driver does a great job of demonstrating how to build a remote task driver. But it doesn't have a great usability story. For example, the actual ECS task that it runs is defined in Terraform, not in the Nomad job file. So it's actually using Terraform. Really sorry that all of my tabs are tiny, tiny, tiny. We define the container definition just in a Terraform file, and then Nomad is just used to spin up instances of this predefined task. So probably not the best usability. It'd be really nice to just kind of have an ECS driver that worked like our Docker driver, give it an image, it runs it. That would be an exciting thing to see happen. But for today, this is what we're going to be using. And so I have that Terraform already run. The kind of, let's see, these windows are pretty ugly, but I think we can use them. The kind of weird thing about this demo is down here, these three squished little windows, I have a Nomad server in my lower left. That's the scheduler process. Then I have two agents running over here in the bottom right. Those are the workers that actually run workloads in your Nomad cluster. They're just running locally on my laptop. None of this that you're looking at right now is actually running in AWS. The driver, the Nomad ECS driver that we wrote, doesn't care where it's running, where the Nomad agents are running. It will talk to the AWS APIs and schedule ECS workloads. So instead of talking about it, let's just schedule it and see what happens. This is what the demo job file looks like. You can see there's a few rough edges, things like the kill timeout needed to get bumped because killing ECS tasks is just slower than killing locally managed containers. There's a little bit of extra work that we make people do by having you define your VPC configuration. That was one of those trade-offs where it's like, well, we could, try to auto detect things through the driver and that sort of thing, but this is kind of the most flexible way that you could choose the VPC on a per task basis. So anyway, let's see it run. Great, looks like it got deployed successfully. Let's take a peek at it in the Nomad UI. So as you can see, it's just a Nomad job. It just has an allocation like you would expect from a Nomad job. And right away on this screen, you can kind of see, though, how remote tasks are fundamentally different. They're just a job, they're just an allocation, they're just a task driver. All of those things are true. But, things like the live resource usage, the driver doesn't implement yet. So we'd have to implement that, and that would have to stream it from ECS. So it'd be a little, more difficult to implement. And there's kind of quite a few features that are different in this remote task driver world. Probably the most obvious ones are things like artifacts and templates. Those run locally on the agent. They do not run remotely in the ECS container. So that's pretty awkward. It means a lot of those built-in features that you're used to may not just work out of the box. And that's kind of why we have this experimental label on this whole thing. So we can explore this problem space, let people play around and see what solutions we can come up with. But diving into what we have today, you can see it's just a normal task. It got started. We can peek at it over here if I can get zoom out of the way. Yeah, we have a running task in this demo cluster in AWS. And there it is. You can see the ECS task running. Yeah, and so now, great, fine, whatever. You could actually have written a task driver like this, and the user we're working with did write a task driver like this even before Nomad 1.1. So what does remote task drivers actually do? And what it does is it makes support for draining and down nodes better for remote task drivers. Because if we drain the node, the Nomad node that this ECS task is running on, there is no reason to interrupt this ECS task. It should just keep running. It does not care that the Nomad agent monitoring it. and managing it is gone, it can keep running and a new agent can take over managing it. So that's what the remote task driver really adds. So let's see that in action. Let's do it with a drain here first. So I'm looking at the allocation for the remote job. And we can see that it's running on clients. Ironically, the name starts with EC2. It's not running an EC2. It's on an agent on my machine. That's just the random ID given to this node. Drain this node. It drains quickly. You can see that that allocation running the demo is drained. It's marked as complete. The drain is complete. This node is now ineligible for scheduling. And so if we hop back over to Nomad ECS demo, you can see there's one running and one complete. The complete one is the drained one. The running is the replacement. Scroll down to look at allocations. You can see the new allocation is on the other client, again, running just on my local machine. So it's a new allocation, but if we head back over to Amazon and hit refresh, it's still the same old ECS task. So this is just showing that even though we drained the Nomad client, we did not interrupt the ECS task that's running. And that's kind of one of the big benefits we wanted to offer people with remote task drivers, is the ability to not only manage tasks remotely more easily, but to not let Nomad operations unnecessarily interrupt work. There's kind of two core features that do that. You want me to, Jackie, should I dive into the nitty gritty really quickly, or am I just talking way too much?
I mean, chat's been mostly quiet. We're just back and forthing about CSI a little bit. I was literally mid-typing as you asked, but I think it's fine. Like we've still got time, and if questions come in, we can just surface them. Yeah, seems good to me.
I'll be honest. I would rather talk about this than CSI. So I'll go for this. No, CSI is great. I'm glad people are talking about it. It's just it's complicated. I think anytime we have to have per provider plugins and are relying on a third-party plugin specification, there's a lot to test there, a lot to support there. It's a pretty complicated subsystem.
Yeah, I think we just basically need like an entire stream for CSI at some point on its own.
For sure.
But there's some prep needed to get there. So
definitely some prep needed to get there. Yeah.
Yeah.
Yeah. Cool. So I'll just quick dive in because into remote task drivers a little bit, because I would love for people to play with this. I hope that it would be fairly easy to write your own, either a better ECS one, a Lambda task driver, even writing something like an SSH task driver that like runs and monitors processes running on remote hosts over just a plain old SSH connection. I think there's some like really interesting fun to be had. And I hope it is fun to play around with. If we look at, let's actually take a peek at I have it right here. At this driver code. Yeah, I mean, there's plenty of boilerplate in our plugins, things like specifying the version of your plugin and specifying the configuration options for your plugin. All of that is true, but the actual interface and logic we really hope should be pretty straightforward to implement. And again, issues are a great way to discuss problems you run into here. For example, we got a great issue where a user wrote a custom driver, not a remote task driver, just a normal one that had expensive initialization. And there's not a great place in our API to handle expensive initialization. And so they were doing it in the setConfig API, which is how the Nomad agent gives your plugin its configuration. However, right now the Nomad agent calls that twice, once during fingerprinting and once it's actually running your plugin. And so it makes it super awkward to use it for a once and only once initialization. But at any rate, just to kind of show how this is implemented, there's for anyone familiar with Go, it should be pretty familiar kind of Go idioms. You create a new plugin, turns an instance of the driver. There's some informational APIs purely for the Nomad agent and the plugin to get things like information in the configuration schema. Set configuration just handles getting the configuration from the Nomad agent and applying it to your driver, like we just talked about. And so this in the ECS driver, this is also where we configure the AWS SDK's client. Just things like plumbing through the region configuration from the Nomad client to the EC2 client or to the AWS client. Trying to get to the fingerprinting is let's see. Capabilities. I'll kind of show here in a second, but again, just kind of more metadata to be returned to the Nomad client. Fingerprinting then is more metadata to be used by the Nomad agent and by the Nomad scheduler for scheduling. It's where you can tell the scheduler whether or not this driver is healthy or unhealthy to prevent scheduling. Say the credentials, the AWS credentials are incorrectly configured on this Nomad agent, then it could the client could report itself as being unhealthy so that it's not trying to schedule remote tasks onto a client that is unable to run them. Kind of starting from the middle of the logic, sadly, but recover task is what Nomad calls when the Nomad agent is restarted, and we need to reconnect to remotely running tasks. And so here, let's see. I guess the actual AWS SDK calls are wrapped up in this get method here. But that's where you would see if the ECS ARN is still active and running. And if so, you report back that the task is healthy to Nomad. If you're starting a task for the first time, or if you're trying to recover a task and it died while the Nomad agent was restarting or something like that, then start task is, kind of the main thing you need to implement in any plugin driver. And let's see. Yeah, you can see right here, basically calls through to the AWS SDK, passing through some driver configuration. This is just a light wrapper that converts from Nomad's configuration to the AWS EC2 or ECS configuration. I'm probably saying the wrong acronyms every other time. I'm sorry. But yeah, then we just track your task instances by the ARN. And we make sure to save that. And that's how we recover it. And that's how we reconnect to it. And so the interesting thing about remote task drivers is all of this could have been done without remote task drivers. But what remote task drivers added is the ability for this task state to be transferred from one allocation to its replacement allocation. So what that means is, remember when we ran this job the first time, it created this first allocation, started the ECS task. Right down here, started this first allocation, but then we drained this client and it created a replacement allocation. So the first allocation actually created the ECS task, got the ARN for it, saved it in, this task state. That task state got saved all the way up in the Nomad servers. And so that way, even if instead of draining, say we would have lost that client entirely, say that client just crashed and died, then when the Nomad scheduler would notice that, it would schedule this replacement allocation, just like happens with a drain. And what remote task drivers do is the Nomad scheduler will give the replacement allocation that ARN, that task state from the original allocation. So this is kind of the first time we have ever allowed sharing state from a previous allocation to its replacement. And it's specifically to support this use case of reconnecting to allocations that might have survived a drain or might have survived a node crash because they're running remotely. There's one other trick to all of this. And let's see if I can find that. Yeah. Stop task. So stop task is another one of our core APIs for when you're writing any task driver, whether it's remote or not. But remote task drivers have a detached signal. And so a signal is just like a Linux, any old Linux signal, if you're familiar with those, sig term, sig quit, sig hup. But we created a special one that is sent only to remote task drivers to tell them, don't actually kill the remote ECS task. This node is just being drained, so just detach from the remote task. You're not the one managing the remote task anymore. And so remote task drivers should just look for that signal. And if they see it, don't kill the remote task, just walk away. And that's what you do on drain. And that's also what a Nomad client would do if it was down and its allocations were marked as lost. So once an allocation is marked as lost, it's replaced by a new allocation. The new allocation will connect to the remote task drive, the remote ECS task. And so we don't want two different Nomad clients managing the same ECS task. So the old one is told to detach. So yeah, if you follow, this Nomad ECS driver that we've created, it should kind of outline or be a good template for how to write your own. You can hopefully easily imagine how, really all of the code in here will look the same probably for any remote task driver. The actual AWS ECS specific code is all hidden in this like little handle stop method here. Can we jump to that? Oh, it's just canceling context. I was seeing if we can actually show off the actual calls. Yeah, you can kind of get an idea in here. This is where we're monitoring remote ECS task state, actually making ECS calls. But as far as this driver.go file goes, this is probably going to look about the same for any remote task driver. So it should make a good template. And you can kind of just replace the ECS calls with whatever your chosen remote task needs. Yeah. Oh, capabilities. That's the last thing I should mention, because that is what enables all of this. All task driver plugins advertise their capabilities to the Nomad agent. And so they advertise things like the file system isolation, whether they support remote execing into the container, whether they support sending signals to the container. Like I said, this ECS task driver doesn't support a lot of Nomad features, so those are explicitly disabled. If you set remote tasks to true, that's what tells Nomad to support that detached signal. Make sure to propagate my task state to replacement allocations. This is what really enables all of the remote task driver specific functionality. So yeah, so that's kind of how remote task drivers work, the problems we were hoping to solve with those. We'd love feedback. And feedback, a future form that this could take is kind of a bigger idea we had was to have group drivers instead of task drivers. So instead of just a driver for a single task, maybe a driver for an entire allocation that would run multiple tasks all within a single ECS task. I don't know. That would be a much bigger effort, but we are definitely open-minded about this and would love people thinking about the problem and letting us know how they want to use it. Lots of options for the future. There should be, last thing too, there should be reasonable documentation as well. If you go to task drivers on Nomad Project.io's docs. There's a remote task drivers section. There is one known bug here that is kind of outstanding that will fix with it. That basically the workaround is to make sure that you run more than one client with the remote task driver installed. Reconciliation may not work if there's not capacity available and a remote task driver node goes down. All part of a tech preview, sorry. But yeah, should have good docs, should have docs of the plugin development documentation. Kind of describes, what that remote tasks flag that I was talking about earlier does. Yeah, file those issues, write some remote task drivers. I'd love to see what people are able to do.
Thank you so much. And this is kind of what I mentioned a bit earlier in that we're going to be trying to this is us trying out doing a tech preview. So if you're watching and you have feedback for us, we'd love to hear it. Either, I guess, me as a DA, I'd love to hear if you liked having tech previews, if you would like more demos, more previews, things like that. We'd also really like to hear your use cases. And I'm going to stop because I think Charlie still has something to show us as well. And I'd love to kind of give you the floor so you can do that too.
Sweet. Okay, so we're going to try and do a live run through of some work I did to make a guide on memory oversubscription, and this will be an adventure. So let's see how it goes.
Oh, is your before we get started, is your guide live? And yeah,
It is. Yes.
Nice. Okay, I will get a link for it to drop it. Okay, I'll drop it in chat after your demo then for anyone that wants to go check it out as well.
Cool. Y'all off the thing there. If anyone hollers out on, okay, so here's the actual guide itself. I'm gonna cruise back up at the top. Sorry about being at the bottom. Just oversubscribed memory, and it's here in the advanced scheduling topic section. And so what we're gonna do in the guide, as soon as I can resurface my shell. Resurfacing the shell. All right. So I've deployed my monitoring job, which is included with it. It's just a little bitty InfluxDB job. I have to say I used Influx because their colors are so pretty. I couldn't help myself. All right, so let's see. What I've got is I've got a job in here called wave.nomad. And wave.nomad, actually, let's go ahead and peek this real quick. Oh, wait, I'm on the server. Let's Vim. Wave.nomad is a little Docker job that is just designed to use memory in a fun, predictable way. It's a little container, but I also have the code for the container in the repo for the guide. So if you want to build the container yourself because you don't trust me, which is wise, you can certainly do that. Otherwise, it's hosted at my GitHub, or my Docker Hub, rather. And Wave is going to use more memory than it is allowed. So our expectation is that it is going to die on run. I got a job. Okay, so we can see it starting up. I'm gonna flip over to monitoring. And I'm going to bring up my really pretty Prometheus situation. Or not Prometheus, Influx. He said. There we go. This demo uses extremely secure credentials. Oh, one password, I don't want to save it. All right, so here we are, and this is just the dashboard. Oh, I have a board called the Wave dashboard. And we're gonna be able to sort of watch what's happening. Let's make this time frame not an hour. All right, now, oh, no, Just kidding. All right. Important to remember what you wrote a long time ago. Right now, the current wave job does not die. It runs to show you what it will look like. And it's below its max memory utilization. So right now, it uses 500 meg. We gave it 520, but we can see that there are these peaks and valleys, and we could maybe use some of this empty memory, thinking about, wave is contrived to be sinusoidal, but imagine you had a spiky workload or a Java workload that was very heavy in the front, but then all of a sudden you reclaimed all that memory. Well, you wouldn't want to chop that off. So what we can do is we will come into this job here, and we're going to do a little bit of modifications straight up in the UI. Edit. Where are you at, resources? And we're going to give it slightly less memory. Let's say 400 meg, which we know is under what it needs. So now we anticipate some killer behavior coming into the party. We're going to plan that. And you can see that we're going to cut the memory down, and we're going to apply that, which means we're going to get a new instance. Let's go watch dashboard. Let it sort of sort out its life. And all right, so here we go. There's our new allocation starting, and a little bit of overlap from the stop. And what we're going to see is that this allocation is going to die. And it is going to die repeatedly. It will be killed. And so now we can start to see kill events. Like there was one. I have no idea why it says 0, and that makes me not wonderful. Oh, there we go. Okay, now I have a step. So yes, so we started to see some kill events, and that is because our container, as it approaches this memory mark, is killed by the operating system. And so what we want to do now is we'll stop that job for a moment. And we're going to jump to the CLI. And I'm going to go borrow a little bit from the guide here real quick. I'm just going to tear this off and slide it over here. And so we're going to, in order to look at the current scheduler configuration, I'm going to curl the scheduler endpoint and see what it says it's doing. And right now, it's got the default of memory oversubscription enabled turned off. So we don't, by default, memory oversubscription is not enabled. You have to turn this on yourself. In the guide, there's actually a little bitty handy dandy snippet that will do the update for you in line. I should scroll down a bit. But it will, and I'll actually paste it in here and I'll sort of talk through it really quick. Copy. All right. And all this does is it uses JQ to do a sort of a get, mutate, and reput, which is handy and shortcuts. And I can see right here that my configuration was updated. Let's go ahead and refetch it just to make sure that everything is cool. I can see now that memory oversubscription is enabled. So now I should be able to go back and run this job, given its 400 meg limitation. And we should be able to run the job just fine. So let's see how it does. And Wave dashboard is hanging out in there. I will say that one of the fun things for me on creating this demo, and I probably spent more time on it than I should, was writing a job that could use memory in a predictable fashion. Because
it's hard.
well, and everything wants to prevent you from everything wants to garbage collect in its own time or whatever. And so in order to have my malloc behaviors, oh, I forgot one thing. Golly, this live demos, they're going to do it. Okay, still died. Why did it still die? Because I need to update the definition. Let's find resources again. And I need to provide 2 values now. If I click update or edit, let's see, maybe. No, I did not. Oh, there we go. Oop. All right, here we go. Come down here to resources. I have 2 memory options now. I have memory MB and memory max MB. And in the job spec, it's memory and memory max. Those 2 values now create a soft limit or sort of a expected value that is the build against for the scheduler. And the max is an enforced hard limit still. So you can prevent a job from running away and eating all of your memory even still. And still allow for oversubscription. So I know that that job doesn't use any more than 520 meg right now. But I want to be able to have it run in as little as 400. I only want the scheduler to bill for 400 meg. So now I'll go down here and I will plan this new version of the job and I will run it. And now it should not die. And what I expect to see is that the job memory use will actually go above the blue line, because the blue line is the allocated value, the allocated value, which maps to the memory resource request in the job. And we have to sort of wait until the new allocation starts feeding in some data. Oh, dashboards. Come over here and peek and make sure that everything started. Uh-oh. Oh no, okay, it's running. It says, why are you trolling me? Okay, I think I got bit by the multi-node bug, or by, I did not design this demo to be multi-node. So the influx is not multi-node. I am scraping a single client's statistics. Shame on me. And then I tried to run it in my real cluster. Fiddlesticks. Okay. Hold, please. I can save this. I have 6 minutes.
I'm starting to think this is the demo that whenever we do it live, it's just like, oh, did I work not live? Yeah. Is it time to do it live? Like, because this is a different memory oversubscription demo than the one I did, but it feels like we're at roughly the same spot with like not the same problem, but like just
There's while Charlie's setting this up, one other cool thing about memory oversubscription is that Nomad will not let you schedule a job on a host whose total memory is less than your max memory. So let's say you have like a big data intensive task that needs 100 gigabytes of memory. It will or spikes up to 100 gigabytes, and its normal amount of usage is somewhere around 80 gigabytes. It will not schedule that onto a node with just 96 gigabytes of RAM, because 96 is less than that maximum of 100. So it would make sure to only schedule it on something with 100.
Let's see. What it probably is going to end up happening is, yes, okay, my influx moved, which was expected to, because I drained all of my nodes but the one. So let's go and see if we can reopen monitoring. New allocation. It's IP. So actually, it was very interesting to write the influx job because there was a lot of dance of configuration. And so I got to really sort of stretch on how to synchronize timing. Slightly less fat fingers. Board, dashboard. And we'll give it a second. Let me make this 5 minutes. Let me make this 5 seconds. And now, like we can see from the first data points, that it's actually using, it has used more than the bare minimum resources. And if we sort of watch over a period, we'll see that it will come back over it again and not be killed. So yeah, so right now we're about to cross the 500 meg mark. And there we go. So now we're maxed out on its expected usage, and it'll ease back down. But this was just a workload that was fun and predictable and user configurable. I really want to later add more options for how it burns memory, but sine waves were the prettiest, neatest way to start. This was inspired by Michael Lang / nerd trolled by Michael Lang. But I ended up building it in C so that I could really get hands-on, and it's gross, but fun. But yes, so there is an oversubscribed or an oversubscribed job running. It only wanted 400. It can use up to 520. It's using 500. Magic. And the demo, the guide will actually walk you through all of these steps and includes the dashboard and the sample job code and a Docker file that can be used to build the sample C code. So if you really just want to get all up in it by hand. All right.
Speaking of the guide, I'm just dropping it into chat right now with a here it is for anyone interested in checking it out. Yeah. I think we have like a couple more minutes. So if you had any questions still that you wanted to put in like right away, we can still get to it while we're here. But yeah, thank you for doing the demos. This has been really fun. It's actually kind of nice to just bring some demos into office hours and get some feedback. And I've really been enjoying the conversation in chat so far. I kind of want to talk to everybody about what they want to build. Like, so I'll just give it like a couple more seconds and see if any questions come in. And if not, then we can start wrapping up.
Yeah, and like with remote task drivers and CPU cores, you know, there's more that we can do with memory over subscription too. So don't be shy about asking for more goodies around that. I think it was Facebook published their custom killer years ago. I think that they were the first ones that I kind of posted a really good deep dive on the thinking into that. And Nomad doesn't do any of that right now. It relies on the Linux kernel's built-in killing logic, which does take into account the soft limit versus the hard limit and all that sort of nice stuff, and should work pretty well. But as anyone who has hit the killer knows, it rarely kills the thing that you would want it to kill. So yeah, it'd be interesting in the future to see if Nomad can fine-tune that a little bit better. Since we know more about your workload, things like priority, you can put a priority on your jobs. We know that the Linux kernel doesn't. We could absolutely take that into account in killer logic.
It looks like we don't really have any more questions coming in. So I guess we're gonna move into wrapping up. And just thank you again so much for coming on today and doing these demos. I have opened up speaker notes from June 4th, which is definitely not what I wanted, but nice. I love when things have the same name. That's on me. Let's see, was there anything we wanted to share? I think just coming back to our notes, let's see, we had some demo repositories if we wanted to share those with the audience. I think we talked about how if anyone was interested in contributing to our ECS driver or similar, that we could share some things for them too. I talked about before the live stream. I don't actually think we've said that live yet today.
Yeah, there's the ECS drive. Did we post the ECS driver. I mean, Nomad Project IO should have everything we talked about today in fairly obvious places. But yeah.
Yeah, I've sent that one because it's like a specific other link too. Yeah, I think that's actually pretty much everything I have. I have like my own demo code if anyone's interested in playing with that we didn't do today, but that's shameless self-plug. So and then with that said, the next community office hours is actually going to be on Thursday, and I believe Cole will be hosting it for the Terraform CDK team. Wow, cycling through tabs while talking is kind of hard. Just trying to find a schedule as I die while we're on a live stream. But yeah, I guess, is there anything else that you'd like to share before we stop for today?
No, thanks for joining us, everybody. Thanks, and thanks to you, Jackie and Charlie, both for putting this together.
Shantanu did pitch one last question there about the tech preview driver. Does it need Terraform?
Oh, does it need Terraform? Terraform is used to set up the, it doesn't need it. Terraform is there for the demo, to set up the ECS task, to set up the VPC, to set up, all those dependencies for the demo. But the task driver itself, nope, doesn't require Terraform. You can configure it any way you want.
Awesome.
Fantastic. Well, thank you so much, everyone, for joining, and I hope you all have a great week. It is actually early in the week, true. And thank you again for both of you coming on and doing the demos. And if you have feedback for us, please share it on the forums or at me on Twitter, or really wherever you feel the most comfortable sending a message. We probably want to hear it. So yeah. And thank you so much for joining, everyone, and have a great day.